In this mandatory video, we are continuing on talking about proofs. We did proof number 1 on day 6 together. We have listed here on the notes the 5 ways to prove triangles congruent. So if you need to go back and take a look at any of those 5, you may do so. Question number 1 we did together in class, and question number 2 we're going to do together now. Please remember, one of the things that we did discuss in class is that when we're working on proofs, it is important to remember that they must be colored. So for proof number 2, we're going to treat this the same way as we did on proof number 1. We have a 2-column proof. Column number 1 is all of the statements. These are the things that we know to be true statements about the problem. And the reason column basically is telling you, or whoever's reading your proof, why we know those things to be true. You can see statement number 1 does list 2 important facts, and according to statement number 1, the reason is that it's given. So in other words, that information comes with the problem. I think that's important to note, that things can come with the problem. Instead of putting them in paragraph form, they've written them in a proof form. If your paper does not have a statement reason chart drawn on it, that means that you draw your own. If you don't want to write out the whole word statements, you can abbreviate it STMTS, and reasons RSNS. Please note that just an S or an R is not acceptable. So when I take a look at the first piece of given information, I can see that they're telling me in the very first line that line segment AC and line segment BC are congruent to each other. When I look at what the prove line says, the prove line says that I am supposed to make the triangle on the left congruent to the triangle on the right. And what I do notice about the yellow line segments that I just colored, the yellow sides of the triangles, is that I can tell I have a side in one triangle congruent to a side in the other triangle. So in my goal of making triangles congruent, I'm off to a very good start. If I move on to the next given piece of information, what is told to me is that I have a midpoint along the segment that goes from A to B. So there's a segment that goes from A to B, and right in the middle is what we call the midpoint. And what we learned in a previous unit is that when we have a midpoint sitting on a segment, the 2 parts will be equal to each other. So what I can say from the fact that I know that I have a midpoint is that the segment that goes from A to D is congruent to the segment that goes from B to D. The reason why I know that is because midpoint of a segment divides the segment into 2 congruent segments. And what we're doing is we're listing those 2 congruent segments. And what you know about this is that with a segment and a midpoint, your 2 parts are not only congruent, but they do divide. The midpoint does divide the segment into half, but we're not listing the half parts here. We're just listing the fact that our 2 segments are congruent. What I also notice then is that in each of the triangles, I have one side congruent to another side. Remember, I'm keeping track of congruent sides and angles until I end up getting a pattern that matches exactly what it is that I'm looking for. One of the 5 ways to make triangles congruent. So when I have run out of givens, in other words, I've used the givens and there's nothing else there, that means I turn my attention to my picture because there must be something in the picture that I can use. So when I look at my picture for things that are congruent to each other, one of the things that I notice is that this segment CD, congruent to CD, is reflexive. In other words, if I was to split this picture into 2 triangles, there would really be 2 segments called CD, one segment in the left triangle and one segment in the right triangle. So because I have basically CD congruent to itself, I know that I'm getting another set of congruent sides, and in line 3, I need to write down that segment CD is congruent to segment CD. My reason for that is exactly what we did in example number 1. It is reflexive. As soon as I know that I have accumulated 1, 2, 3 pieces of information with respect to the two triangles, I want to say, do those pieces of information indicate to me that I have enough information to make the triangles congruent? And what I notice in this case is that each triangle has 3 sets of sides congruent to 3 sets of sides. So in the first triangle on the left, I've got a yellow, a purple, and a green side, and in the triangle on the right, I have a yellow and a purple and a green side. So now when I'm looking at this, I have gathered enough information to make those triangles congruent. So I'm going to say that triangle ACD is congruent to triangle BCD. And when I go to list the reason why, I'm sure a lot of you already know that the triangles are congruent because I have 3 sides in one triangle congruent to 3 sides in the other triangle. So side, side, side is going to be the way that I prove those triangles congruent. So just a short little video that was probably necessary for you to know what to do on your homework tonight. Just as a reminder to you, every time you go through and use a midpoint, that's the reason that you're going to use. Up above in question number 1, we used a reason angle bisector divides the angle into 2 congruent angles. Every time you have an angle bisector, that's the reason that you're going to use. So those reasons for the angle bisector in the midpoint are going to show up again and again and again. This reason, reflexive, is a reason that says that anything is congruent to itself, and in a lot of cases what that means is that's going to be the shared side between the 2 triangles. And then of course when we get into number 4, when we're looking at this, remember there are 5 ways to make one triangle congruent to another one. This is one of the 5s, and I picked this reason because I had 3 sets of sides congruent between the 2 triangles.